class with me. My name is Ming. Today we're going to look at these learning targets. I am able to use integration by parts. So we're going to start by looking at the formula. This is the formula of integration by parts, and you may want to question, well, this looks very complicated. Where does it come from? Well, actually, it comes from something very standard, that is the product rule. You can think of UV at the moment as two function of x, and we need to take the derivative of this particular product. So this is our product rule. And now what we can do is that after taking the product rule, we reverse the process. That is, take the integration both sides with respect to x. So I put in the one in red, and you can see that now. dx cancel, dx cancel, dx cancel. In fact, the first term here can be treated as after cancelling is just d of uv. That's the product. So what is that equal to? Well, that is just equal to uv, the product itself. So with this, we will get to this simplification of this, and then treating the second term here, or in the right hand side, as my subject, I can rewrite this as uv minus the integral of v du. And this is basically what is given here. And the thing in the box, the blue box, is this one, the colorful one, the green and the red. Sometimes it's easy to think in terms of the simplified version. Sometimes it's easier to think in terms of the one in the box. So let us try to memorize this method. So sometimes it's easier to think of this product as u times dv dx, this way. And u is where I think of u for ugly. Why is it ugly? Because I cannot integrate it. I can only differentiate u. And then the nice part, dv dx, is where I will integrate to get v. So here's the process. You identify the part that you can integrate, that called dv dx, and the result is v. And second part, we keep the u in the first term, the blue one, in the first term, and then the result of the integration, v, in the second term, like this. But note, there is an integration sign in the second term. And then last is that you differentiate u with respect to x in here, and we integrate v du dx, for example. So let's look at an example. Here we have integration of ln x. That's only one term. Where is the other term? Well, you can think of this as 1 times ln x, for example. And which is the ugly part? That is the part that you can only differentiate and not integrate. Well, we cannot. The ugly part will be, so consider this as that. So the ugly part is the ln, because I cannot integrate it, because if I can integrate in the first part, I don't need to put in the 1, right? So u equal to ln x, and then dv dx is equal to 1. And after that, we rewrite du dx, not rewrite, I mean take the derivative here, du dx is equal to 1x, and then integrating this become v equal to x, because I have to integrate dv dx with respect to dx, and then integrate 1 with respect to x. So this is what I will get. That is v equal to x. Now, after we've done that, I can plug this into the formula, this particular formula. So uv minus integration of v du dx times dx. So what is u? Well, my u is natural log of x, and v is my x, and then integrate x times 1 over x dx. Basically, this is x ln x minus the integration of dx. And What is that? Well, we're almost finished. So that is equal to integration of dx give me x plus c. So basically, this is my final answer. Usually, it will be a good idea to check whether your work is actually correct. To check is that you assume your final answer here to be y, and then differentiate it. If you get back the same integrand, then your work is correct. So if I differentiate this natural log of x, x ln x minus x, I start by differentiating x. So I get natural log of x, and then after that, differentiate ln x, give me 1 over x. Basically, this is the product rule, minus 1 plus c, that is plus 0, constant. Derivative of a constant is 0. So this is what I get. Okay, thank you very much. Make sure you see the next video to study the next example.